Okay, hope everyone is doing well and having a great day. This is Michael McClellan. I'm with L3 Levine Electronics and Electrics. Welcome to another webinar. Today we are very fortunate to have with us Richard Traver of ESL Emergency Power Systems. Just a couple housekeeping items before Richard gets started. This is a webcast, so your phones are muted, but we would love for you to interact with us and ask questions. There's a question box to the right side of the screen, and please push that button and you will be, a dialog box will pop up and you can type in your question. And we would love to answer those questions at the end of the presentation. And at this point, I'm going to turn it over to Richard Traver.
Good afternoon, everybody. This is Rick Traver with ESL Power Systems. Just a quick background, ESL Power Systems is an employee-owned company that deals with interconnection of various types of equipment and systems. We have four main product groups, which entail shore power and refrigerated container connection and locomotives and a number of other types of industries. But the focus of our company is to safely connect and disconnect from power. The emergency power group then deals with mostly the connection and disconnection of portable and permanent generators in a safe and user-friendly manner. So we're going to be talking about emergency power connection equipment and how it relates hopefully to some of the applications that you see and how the ESL power systems units are very adaptable and very customizable to your specific applications. So the product group is going to be broken up into really four different categories. We have our StormSwitch, which is our manual transfer switch, just like an automatic transfer switch, except the sequence is started manually, turning a handle, pushing a button. We have our load bank testing and portable generator connection, our TripleSwitch. So that's where if a permanent generator is involved and you need to back it up as well as load bank test it, we have an all-in-one integrated system that will do that. We have our generator docking stations, which are basically your enclosures with cams that are hooked up to some sort of transfer device, typically one of those two above it. And then we have power outlet boxes, or OutTap, which can be used as another form of quick connect for load bank testing, or is quite commonly used to provide power out from a facility to remote equipment, such as lights, chillers, other types of equipment that need power and you don't want to bring in a portable generator. So very popular at remote locations. As we talk about this equipment, we want to keep in mind the proper UL listing for the type of application that the equipment is intended for. And UL, as you know, has very specific listings so that equipment is used properly for its intended use. So it's quite common to see UL 98 because that's kind of a catch-all for enclosed dead front switches, usually used in large switchgear and switchboard applications, which may or may not include the capability to transfer power. UL 50, you'll see on a number of types of equipment, but keep in mind UL 50 is just for the enclosure. Has nothing to do with the assembly, how the whole thing operates, the individual components. It's just a listing for the enclosure itself. And you'll see lots of equipment out there that when you look at what they're UL listed as, it's UL 50. So you would want to dig a little deeper. We'll talk a lot about UL 1008 because that is the proper listing for a transfer switch, where the intent is to switch between power sources. Those sources could be utility to a permanent generator, utility to a portable generator, a UPS system to a solar system, utility to a UPS system, but wherever you're switching power. All your automatic transfer switches are going to be UL 1008 listed. So when you get involved with manual transfer switches, you'll want to have a seamless design and a seamless application where everything is properly listed per the application. And going through UL 1008 means that you've done a complete assembly test, things like heat rise and overcurrent protection and water resistance, how the thing is constructed so that from an installation standpoint, there's enough room in there for the number and size of cables that are typically required, and the installer has plenty of bend radius. So little things like that can be very important in keeping the cost down to your installation. UL 891 is for a dead front switchboard, and we use that with our OutTap. So that's power going out versus, for instance, UL 1008, where you have power coming in from the generator. UL 1773 is for termination boxes. That's basically cable in, cable out. And we do make some termination boxes from time to time because we are a custom supplier and we do have a 508A panel shop. We do get requests for custom termination boxes so that they fit a certain size, certain dimension. We can orientate the lugs in certain positions and certain orientations. That's the proper listing for that. So keep in mind those proper UL listings as we talk about these various applications. When we talk about our standard product, again, we're going to appropriately list it UL 1008 or UL 891 when we talk about typically things that have to do with generators. Your enclosures are going to be standard is going to be a galvanneal steel, powder coated, a wrinkle gray. Keep in mind that if you have a specific color that you would like for your unit, we certainly can do that. We go off of the RAL color chart. But if you have a Sherwin-Williams color or a military color, we can usually fairly easily cross-reference those and supply you with the color of your choice. Keep in mind, there usually is a small custom color charge for that. Not always, because certain colors are kind of standard default colors that we can get without a custom charge. The units are built to a NEMA 4 standard and labeled NEMA 3R. So NEMA 4 means that when they're not in use, they're pretty much waterproof. You can put pretty good pressure hose to them and water would not intrude. But we label them 3R because you can see in the photo at the bottom there are holes in the bottom of the unit where the cables from the connection of the portable generator connect to the cam locks. So when that flap is in the up position and cables are in there, obviously the unit, even though cables are going through there, would not be waterproof. And therefore, these are always labeled NEMA 3R for weather resistance and outdoor use. The connectors you see are your standard Series 16 400 amp rated CamLock quick connects. There are a number of different manufacturers for these connections, but they're all interchangeable, and it's a very easy connection, much easier than trying to connect inside cable into a lug. It's a quarter to a half turn, and they're securely now locked in. Units will come in two different styles, wall mounted or pad mounted. The wall mounted units, if you're not going to mount them to a wall, can be provided with optional lay kits. Most of the units are mounted to a wall, or if they are going to be on concrete or remote, typically there is a unistrut or some other form of connection trestle that other equipment is also being mounted to. But if you need to mount it remotely on a pad by itself, lay kits are available. Pad mounted units come with side wireway standard. 98% of these applications have bottom feed, so we include the side wireway so that you can easily bottom feed any one of the pad mounted units. Along with our standard offering, then, there are a number of different options that are fairly common. These are not all the options we offer. It's pretty much anything you can think of. We've supplied it in one form or another. These are the more common ones. Phase rotation monitor, that's the little orange square you see up there in the corner. That's so when you hook up your portable generator, you know it's in the same phase as your utility. Fairly common, although a lot of people realize that they can do the same thing from the portable generator itself. So it's just something as a preference. You have the utility indicator lights, so you can see the little red light on the side of the unit. That can be red, it can be green, it can be on the side of the unit where you see it, it can be on the top as a strobe. Again, very flexible as to what we can provide, and all of those are available, so you know whether the utility or the generator is being used. And in certain applications, it may be a generator permanent or a generator portable. There on the side at the bottom, you can see a receptacle. Again, very flexible. They can be twist locks, they can be GFCI, they can be standard 120, they can be 20 amps, 30 amps, 50 amps. Again, whatever you need for the application. But those are there. So if you're going to pre-stage your portable generator, you can hook up a battery charger, a heater of the portable generator, auto start signals, things like that. Inside the unit, we can provide numerous terminal blocks for accepting remote signals of many different types and varieties. Very popular again at wastewater treatment, water treatment plants where they're doing a lot of monitoring. So you can bring in various signals in conjunction with other options inside of our unit. We can supply the unit with strip heaters. They serve two different functions depending on where the unit might be. In colder weather, you're going to use it obviously so the door doesn't freeze shut during an ice storm or extremely cold weather. In the more humid climates, it's used for humidity control inside the unit. It helps to eliminate condensation inside the unit, so you don't get any condensation inside of it. The heaters come standard with both a thermostat and a dehumidistat. So depending on what you need it for, you can use it for either thing. On the breakers themselves, We use shunt trips so that they can, again, accept the signal to automatically open. Aux contacts, so you can determine whether they're open or closed or monitor other certain functions using the aux contacts. The units are available in 304 or 316 stainless steel. The designation for that now is NEMA 3RX. So in the old days, a lot of engineers would want stainless steel enclosures, so they would put a designation on there of NEMA 4X, because 4X was for a enclosure that was waterproof but was stainless steel, used a lot in the food industry and in other places where wash down was necessary. Well, these units aren't washed down, so they came up with a new designation, NEMA 3RX. On our TripleSwitch, TempTap, and OutTap, for bottom feed applications, we will provide the unit with an extended enclosure so that the conduit can come up behind the cams. In those three units, the cams take up the entire bottom. So if you want to bottom feed those units, which is very common in new construction, we can provide it with an extended enclosure. The StormSwitch, the manual transfer switch, has an area on the lower left side that will allow for bottom feed. So again, these are all common, but we do things like surge suppressors, voltage regulator meters, a number of other functional pieces of equipment that your site may require. As we start to talk about the equipment, I think it's important that we review the NEC 2017 code that pertains to permanent generators. We see a lot of the various applications, especially in water, wastewater treatment facilities, where they have critical permanent generators that fall under legally required systems. And NEC 2017 703F talks about legally required systems as a single source have to have a means to be backed up for when the permanent generator is down for maintenance or repair. What is legally required depends on the city, county, state, or federal government saying that it is legally required. And various communities will have various codes and statutes that state, for instance, that if you're a assisted living facility, you have to have a means to provide power immediately if you lose power. Many wastewater water treatment pumps are considered critical. If they fail, they're going to dump sewerage into the lake or stream or ocean or someplace it shouldn't be. And so you may have a legally required system. As part of this regulation, then you can't modify the current wiring system. It's got to be a solution that pretty much will drop in and can be integrated into the current system. It has to be mechanically or electrically interlocked to prevent the permanent source and the temporary source from feeding the facility at the same time. And finally, you have to be able to supply a signal to a remote annunciator that tells the facility that the permanent source is now offline and you are on portable temporary power. So when you have a system like this, our TripleSwitch is compliant out the door. And we'll talk about our StormSwitch, which when we know it is an NEC 2017 application, which is typically a gen-to-gen application, then it too will be supplied as NEC compliant. So you never have to worry about do you or don't you meet it. we'll make sure that the equipment is supplied to meet the updated code. So talk about the StormSwitch. So your StormSwitch is a manual transfer switch with mechanically interlocked circuit breakers and the integrated docking station. So what's important about that is that being that it's mechanically interlocked, it replaces the requirements to have any Kirklock scheme and try and figure out which breaker is the main and which one is going to be the generator one, or I have to go into the building to get the key from the main disconnect source, pull the key out, go out to the unit, put the key in the unit. It eliminates all that hassle. So everything is right there in front of you. Important to realize these units are UL 1008 listed up to 3,000 amps. So just like the automatic transfer switch, this is going to be UL 1008 listed. And when we get into applications where, again, you have a permanent generator and now you need to back it up with a portable generator, and you have to have a means to safely interlock those two generators so only one of them can be on at the same time, you're going to have a 1008 listed unit the same as the 1008 listed automatic transfer switch that permanent generator is feeding through. So something to really keep in mind. The other nice thing is you have your operating instructions are provided right on the door dead front. And why is this important? Well, if you go back to the whole Kirk key scheme, in an emergency, there may not be clear directions for somebody that's not familiar with the system as what they're supposed to do or where the other key is. And this way, you have all the operating instructions are right on the door. So if you're a pump station, a remote pump station somewhere, and you lose power, you got to roll up that portable generator. Literally, anybody can roll up that portable generator, look at the instructions on our door, and know how to turn off the breaker, open the door, connect up the generator, close the door, turn on the other breaker. They got power. They can't screw it up. It's all mechanically interlocked. So having the instructions on the door can be a very critical feature for your unit. And then, as we mentioned earlier, with aux contacts added on each of the breakers, we'll then be compliant with NEC 2017-703F. So in those applications, again, where you have a permanent generator, this is going to be an easy drop-in solution that you put between the generator and the ATS. And again, we'll make it very, very user-friendly, very cost-effective, and a very easy installation for your contract. On our wall-mounted units, those come standard service entrance rated. So again, if you're dealing with a new design and you don't want to have to design in a separate main service disconnect, the utility breaker on the StormSwitch now becomes your service disconnect. And again, you don't have to ask for it if it's 800 amps or below. It just comes with the unit, and if it's going to be the main service disconnect, it's a very simple cable installation to bond the unit to ground. So very, very convenient, can save in some of the costs of design, and again, makes it very user-friendly. On the pad-mounted side, service entrance is optional. And the only reason we do it optional on the pad mounts is that it does add a little bit of cost to the unit. And we don't want to charge you for something you don't need. A lot of these units are for gen-to-gen applications, which would never be service entrance rated. So we don't want to charge you for something that isn't applicable to your specific requirement. So on anything 800 amps, anything 1,000 amps and above, we do want to make sure that we know if it needs to be service entrance rated or not. So when you look at the manual transfer switch, obviously there are lots of different ways that you can perform the function of transferring power from one source to another. And a lot of times it depends on whether it's a new installation, existing installation. You'll notice that these are Series 16 cams. Water, wastewater treatment plants, some of the older facilities may still use older pin and sleeve connections, a single 400 amp connector. Those are available. We can do those kinds of units, and the requirement, though, that you have to know up front is we have to know exactly which pin and sleeve type of connector you're using and the actual item number. For instance, Cavitec, Russell Stoll, Minco, they make a number of different styles. It may or may not have a neutral. There's lots of different catalog numbers for them. So if you require a specific pin and sleeve, we would have to know exactly which one we would need to install. I will tell you, though, that keep in mind using the Series 16 cams, very inexpensive to get the plugs and the matching receptacles to use with the portable generator. So even though in the past you may have used a pin and sleeve type of connection, it would be something you really want to consider and talk to your L3 representative about, as far as maybe starting to transfer over to using the standard receptacles. So again, when it comes to StormSwitch applications, first, switching between permanent and portable generators is becoming much more common with the NEC codes. You can see all the other various applications there. Each of them may or may not have certain issues that pertain strictly to those applications. They may require certain features that others don't, or certain kinds of installations that others don't. But that's the beauty of the StormSwitch. It's very adaptable to almost any sort of application. Keep in mind that with the StormSwitch, it allows you to install a solution very quickly and provide your personnel with a very easy and user-friendly way to provide a very critical function if the facility goes down. And it allows them to do it very easily and without any hesitation or fear about, am I doing this correctly? Because you can't screw it up with this type of equipment. From here, keep in mind that the StormSwitch is for a portable generator. So the decision has been made by the company that I need power to keep this facility going, but I don't need it instantaneously. So I don't need the cost and the capital expenditure to put in a portable generator a fuel tank, an ATS, a controller, all the things I would need to purchase a permanent generator to supply instant power versus having just portable power. And if I'm down for a couple of hours or so, I can survive, but I got to have power, at some point in the near future. When the decision has been made, though, that I need a permanent generator, that I have to have power if the power goes out, I need it right now, then you're going to choose a permanent generator. And once that choice is made, now you also have to consider, how do I maintain it? How do I make sure that this thing's going to run properly when I need it, and when it goes down for maintenance, how do I make sure that I still have backup power available? Well, that's where we get into the triple switch. And any place you have a permanent generator, this is a piece of equipment that needs to be considered. I can tell you in the wastewater water treatment, applications, we have districts that have as many as 32 of these units. So wherever they have a permanent generator, they've installed a triple switch. So why the triple switch? Well, it provides a safe and easy and convenient means to both load bank test your permanent generator and to back up your permanent generator, all in one system. All the interconnects are there, all the breakers you need are there, all the places you need to hook up are there, all the instructions to do all of that is right there. So it makes for a very easy, very cost-effective way of maintaining your permanent generator, which is a fairly substantial capital investment. You can see on that picture there, the photo on the left, a triple switch, that's at a wastewater treatment facility in Sacramento. And you can see the instructions right below the handles. All your interlocks and handles are right there. You have your handle cover that will go over there and lock. And so you can see, makes for a very easy and convenient way to function, to do these functional tests and back up that permanent generator as well. UL 1008 listed up to 3,000 amps. Now this is pretty unique in the industry in that UL 1008 in the body of the listing says that in order to be UL 1008 listed, it pertains to male cams only. Male cams by code are used to designate inlet power. This unit, as you can see on the right, has two sets of cams, one male, one female. And yet this is still UL 1008 listed. And that's because we went to UL and they agreed with us that this is still a transfer switch and that having female cams in it was okay. And we had to test it appropriately to get that listing. But now again, you have a unit that's going to connect to an automatic transfer switch that's UL 1008 listed, and now you have a UL 1008 listed transfer switch that's going to allow you to load bank test and back up the permanent generator. So very unique in the marketplace, especially up to 3,000 amps. So what is the triple switch? Well, here's just a quick line diagram. So you can see three breakers, two of them are interlocked, the middle ATS breaker to the permanent generator and the portable generator breaker. So again, you can't have both the permanent generator and the portable generator on at the same time. You have your two sets of cams. You can bring in your portable load bank, hook it up, start your generator. Your middle breaker is still on. If you're running a load bank test and you happen to lose utility power, You can see there's a shunt trip on the portable load bank breaker. Excuse me. That'll take a signal, open up, and now the power from the portable, a permanent generator, instead of going to the load bank, is now 100% directed through the ATS and to the facility. So it meets 700 3F-5 as well. So it's easier if I just play this, I think, and it'll really explain it.
Those that service their emergency and standby power systems are aware of NEC Article 708 and NFPA 110 regulations to regularly test permanent generators and automatic transfer switches. These regulations are in place to ensure that when utility power goes down, the backup equipment will effectively support the facility's electrical requirements. As of 2017, NFPA's National Electrical Code Handbook also includes provision 700.3F, mandating legally required systems be able to connect a temporary source of power for emergency systems that rely on a single alternate source of power, which will be disabled for maintenance or repairs without modification of the permanent system wiring. Well, when used in conjunction with an ATS, the TripleSwitch has got you covered. ESL's UL 1008 listed TripleSwitch provides operating functions during various conditions. When first installed, the permanent generator is hardwired into ESL's TripleSwitch, and the output from the TripleSwitch is hardwired to the facility ATS. Under normal conditions, the center breaker is turned on, connecting the permanent generator to the facility ATS. Utility power flows normally through the meter, ATS, and the distribution panel into the facility. During a utility power outage, a startup signal is sent from the ATS to the permanent generator. Once the ATS detects proper voltage, frequency, and phase sequence, the ATS switches over and power is then provided by the permanent generator. When load bank testing of the permanent generator is required, under normal conditions, a load bank tester is connected to the load bank connection point in the TripleSwitch. The center breaker is left on. Next, the left-hand breaker is turned on. This connects the permanent generator to the load bank connection and also leaving it connected to the ATS. The permanent generator can be started and the load bank testing can be done. When load bank testing is in progress, both the left side load bank breaker and center ATS breaker are on. If utility power is lost during the load bank test, a signal from the ATS is sent to the shunt trip on the left side load bank breaker to open the breaker. Since the center breaker is on, the power from the generator is immediately redirected through the center ATS breaker to the facility, making the switching time compliant with NEC 700.3F5. Anytime the permanent generator is disconnected from the emergency system, such as for maintenance or repairs, the annunciator circuit is activated. A separate portable or secondary permanent generator can be connected to the portable generator connection point during a utility power outage and by turning on the right-hand breaker. Only after the interlocked center breaker is turned off, the portable generator is then connected to the emergency system, providing emergency power to the facility. ESL solution simplifies the traditional connection-disconnection process for legally required systems. The TripleSwitch combines generator quick connects for redundant backup power with dry contacts provided for annunciator circuit at a much lower cost, smaller footprint, and can virtually eliminate wiring mistakes. ESL's three-way manual transfer switch is UL 1008 listed up to 3,000 amps and voltage ratings up to 600. Additional TripleSwitch resources, such as specifications, spec sheets, and case studies, can also be found at eslpwr.com/emergency-powered.
So here's just a brief layout again, showing the functionality of the unit. So hopefully you can see how easy it is and how functional it is to solve a number of different issues that you may have when it comes to maintaining and properly backing up your permanent generator. So it's a drop-in solution. You don't have to, try and decide which breakers that are already in my switch gear or add breakers to my switch gear. None of that. You can just literally install this typically somewhere next to the permanent generator, and you're pretty much good to go. So here's a basic sort of layout riser drawing. You can see the triple switch is between the permanent generator there on the left-hand side, your main distribution panel, and then the main distribution panel goes up to a number of ATS units in the facility. And again, makes for a very convenient design from an engineering standpoint. Again, you don't have to decide where breakers and Kirk locks and all of that may go. This unit just fits in right there between the permanent generator and the distribution. So hopefully this will speed things up for you, eliminate a lot of design time, and provide you with a very user-friendly solution. So the triple switch then is typically any place where you have a permanent diesel generator. We do provide them with natural gas generators. They don't need to be load banked quite as often, but it is still good practice to load bank a natural gas generator. So we do see more and more instances where the end user prefers to have a triple switch there. Since they're going to have to back up the permanent generator anyway, you might as well provide a complete solution, which the triple switch does. So any of these places that have a permanent generator. The tap box, our TempTap, again, is a UL 1008 listed accessory. UL 1008 listed up to 3,200 amps. These units go in 400 amp increments, and that's the rating of the cam locks. But it needs some sort of upstream disconnect typically. So you would use this where if you did have your switch gear that already consists of the necessary components and design for a transfer switch. You already have breakers that maybe do have Kirk locks on them that have been used to switch between utility and a portable generator. You don't want to have to hook up the portable generator anymore to a breaker or to a distribution panel, and you want a quick and easy means to hook it up using cam locks, then a TempTap box is a very good solution in those instances. But you do need to realize you need some sort of upstream disconnect. So if you're either already have a disconnect or you want to mount your disconnect inside the building, a lot of facilities like assisted living facilities, educational facilities, they don't want the actual transfer switch on the outside of the building. So they'll put the transfer switch on the inside and then just mount the docking station to the outside. So another typical means. You can see at the bottom there, that's our 1600 amp TempTap, UL 1008 listed. You can see the amount of venting that it has. There are also fans in there. And that's all to meet the UL specification that you can't a temperature rise higher than 24 degrees above ambient on those cams. So you'll see units of that size that might be 2,400 amps, 3,000 amps. And you got to be leery of that because one, are you going to have enough space to put all the cable in there to hook the thing up? And two, that thing's going to get awful hot, and you need to check and make sure those units are properly vented or have some means to keep the temperature down, because we have seen units where people have gone in and the cams have become deformed, and they literally have to go in and replace all the cams because they can't get the thing hooked up again. So being UL 1008, even though it's just a connection box, is very important. You can see the unit above, that's our 2,000 amp to 3,200 amp enclosure versus the one below, which is our 1,600 amp enclosure. So you can see how much bigger the enclosure has to get in order to meet the UL standard to be UL 1008 listed. So another thing to just be aware of and make sure that the unit's going to be the proper listing. Again, anywhere where you have some sort of disconnect already in place. Now, we can also make this unit with a breaker. Again, if you have a facility that already has a main disconnect and you want to try to utilize it, so you really only need one breaker, we can do that. You'll see an illustration of that here with our OutTap with a breaker, basically the same unit. But we can then put a crook lock on the door to match up to the crook lock that's already in the facility. Same is true with the OutTap. So the only difference between the TempTap and the OutTap is the OutTap has female cams, which designate power going out. So you see this quite common in areas that get quite warm in the summertime, and they'll bring in portable chillers. They don't want to have to bring in portable generators or chillers with their own engines and stuff on them. And that way you can utilize the facility's power and then just quick connect to it and run those, you know, all summer long if you want. So that's pretty common. Again, you can get it with a breaker if you want to have a disconnect source, you know, right at the source of the connection. Most of the OutTaps we sell that are going to be used for remote equipment do have a breaker in them. It's just convenience, safety, but somebody didn't have to walk all the way back in here to make sure this is disconnected when you go to disconnect the power source to the equipment. And then it's also quite commonly used for load bank testing of the permanent generator. We've done a lot of systems previously where we supplied the backup power to the permanent generator. So they had a means to back it up when it was down for maintenance or repair. But now they realize they really should be load bank testing their generator. So the cost-effective solution then is to provide them with just an OutTap and provide them a quick connect means just like they have with the portable generator. And they can then hook up their load bank to the permanent generator without having to get into the generator to do the hookup. So OutTaps with a breaker are the most common use for that as well. That's it as far as the presentation goes. I hope it answered as many questions as possible, but I'm very happy to try and answer anything that you might have as far as applications or anything concerning configurations of the equipment.
That's great, Richard. Thank you so much. We do have a couple questions, and a lot of good questions here that we should share with the audience. One is, are all of the brand name cam style quick connects universal or compatible with one another? And while you're answering that, I'm going to put a poll up on the screen that maybe some of our folks could respond to.
Yes, absolutely. They're all interconnected, connectable. We happen to use Hubble cams, but if you have Leviton or Cooper Krause Hines or Rogers, or we've even tested some of the Korean and Japanese brands with the cam locks, and they all work, they all fit. You just have to make sure that the cams, the receptacles that you have are Series 16, because there are a couple of other series, there's Series 15 and Series 18 that look similar, but they actually don't fit. So you have to just make sure that the receptacle that you have is a Series 16 receptacle, and it'll always say it on the receptacle. It's usually embossed in the receptacle that it's, Series 16.
Okay, the next question is, we have specified TripleSwitch in the past and sometimes have gotten another product. What do you recommend we put on our drawings to ensure that the TripleSwitch is provided?
Great question. The easiest thing to say is that Kirk locks are not allowed, because that's typically what you end up getting, because there's really, with rare exception, I mean, there is one other product line we do know about that uses some sort of mechanical interlock, but 98% of all these substitutions that people try and substitute is they, use Kirk locks and Kirk keys. A lot of times they'll also try to eliminate breakers. And what they'll do is they'll say, here's a less expensive piece of equipment, but oh, by the way, you have to have extra breakers somewhere else in the system. So you're still paying for the 3 breakers somewhere. But in order to make their equipment look less expensive, they're going to make you use Kirk locks and keys, which can be lost and duplicated. And they're going to maybe take some of the cost out of their unit by putting it somewhere else. So the easiest thing to do is say that the 2 of the breakers have to be mechanically interlocked and the Kirk locks are not allowed. And we've seen more of that from a number of engineering firms that have come across the same thing. Or you can just say ESL TripleSwitch no equal. And we have a number of engineers that say, look, I want a TripleSwitch. A number of end users that exclusively use the TripleSwitch, and we'll say, no equal, it's got to be an ESL. And Michael can always supply you with a specific part number for it. And usually, if it's got that specific part number and it says no equal, then that's what you're going to exactly get.
Okay, we have another question. What is the typical lead time for ESL products after the order is placed?
Great question. There are two levels that you have to keep in mind. Placing the order is the first step, but the critical step is the return of the approved signed drawings. We can't start manufacturing something until we know exactly what it is we need to manufacture. So once you place the order, the actual clock doesn't start until the approved drawings are returned. And I make that distinction because you have to work closely with your contractors, with your suppliers, with Michael and his team to make sure those drawings are being moved along. Having said that, once we get the approved signed drawings back, most of the wall-mounted units, triple switches, storm switches, TempTaps, those kinds of things, are 4 weeks or less. Some of the triple switch wall mount units are 6 weeks. The 6 and 800 amps are 6 weeks. Typically the 400 amps are 4 weeks. Then all the pad mounted units with breakers. So your pad mounted TempTaps, 2,000 amps to 4,000 amps. Those are typically 6 weeks. The pad mounted units with breakers, which would be your TempTap with a breaker, OutTap with a breaker, StormSwitch, TripleSwitch, those are all 8 to 10 weeks. Now, I just mentioned something, and I should mention it a little bit further, is that we talked a lot about everything being UL 1008 listed up to 3,000 amps. We do make all of these products up to 4,000 amps, and we are in the process of getting them UL 1008 listed up to 4,000 amps. Currently, if you have a 4,000 amp application and purchase a 4,000 amp unit, those will be NRTL labeled by Intertech out in the field. It's the same method that all our competitors use for their equipment, but we are in the process of getting all our 4,000 amp units UL 1008 listed as well. But hopefully that answers your lead time question. Lots of the wall-mounted units, anything up to 800 amps with a breaker, 1,600 amps in the TempTap, are all what we call min-max items. So they can be as short a lead time as 3 days. But of course, that's a stock item. We're constantly trying to keep that in stock, but things can move very quickly. But just keep in mind that the clock doesn't start until we get the approved signed drawings.
Okay, our final question was, please confirm if the TripleSwitch or any of the products from ESL have synchronizing capability.
That's a really good question that typically, since they have breakers, they can be synchronized. As far as the technical side of how that would transpire, I think it's going to depend on what your requirements are. A lot of times we do have coordination questions, and we certainly can supply the information. We use all square D Schneider square D breakers, so we have all the information needed for coordination and synchronization and those kinds of things. So it's just typically a matter of us fully understanding what the requirements are for this specific application.
Okay, wonderful. Well, Rick, once again, just a fantastic job of communicating all of the different products that have been designed for these different applications. Thank you again, and I hope everyone enjoyed the presentation. And if you have any questions, don't hesitate to email us. And hope you guys have a wonderful day.
Thanks, everybody. Appreciate it.